All right, so I had a couple questions about ions, isomers, and atom structure. And so just reviewing the structure of an atom, it is made of two main parts, the nucleus, which is the center part, and that is going to house your protons and neutrons. Okay, protons are these positively charged molecules, so they have a positive charge and they have about 1 atomic mass unit, so they're fairly large, atomically speaking. And then we have these blank ones, which are your neutrons, and that neutron stands for neutral. They have no charge, and they are also about 1 AMU. Okay, our third subatomic particle that we're going to talk about are these little guys out here, and I'll highlight them in pink. These are the electrons. They are found outside the nucleus, as you can see, in the electron cloud. And they have a negative charge. So they have a negative charge, and they are so tiny that we basically say they don't have mass. So they are 0 AMU. So when we're getting the atomic mass of an atom, we're basically adding the protons and neutrons together. All right, so what happens when we change a proton? So this one has 1, 2, 3, 4, 5, 6, 7, 8, 9 protons. So this would be fluorine. If we were to change that, if we were to lose one and go down to 8 protons, then we would be oxygen. If we went up one, then we would be, I don't remember, but whatever 10 is, it's a noble gas. But it changes the actual atom, so it would no longer be fluorine. Neutrons, if we change the number of neutrons, we're going to get an isotope. And so this has 9 neutrons. If we added 10, if we took away 1 and had 8, then it would be an isotope of fluorine. And a lot of times those are radioactive, but not always. And so sometimes they decay, but again, not always. So that's if you change the neutrons. So change the protons, you get a new element. Change the neutrons, you get so I was trying to move that. You get an isotope. And then if you change the electrons, you get an ion. So this one has 9 electrons, 2 on the first level, 7 on the outer, and it wants 8. So it is going to highly encourage another electron to come over and play. If it were to gain an electron, it would become a negative atom, or it would become a negative ion. And so that is because it's a neutral, and so if you gain a negative, if you're neutral and you gain a negative, then you become negative. Okay? If, however, this was, say, sodium. Sodium likes to give away its electrons. It makes it easier. So if it were to lose an electron or 2 or 3 or however many, then because it's neutral and it's losing a negative, it would become positive. Okay? So that's how you form an ion, is by changing electrons. Isotope is changing neutrons, and if you change the protons, you get a whole new element. All right, so what is an isomer? An isomer, zoom out a little, is when you have all the same atoms, C6H12O6. This is also C6H12O6. So if you look at the formula, you think you're looking at the same molecule. But when you look at the structure, you can see right here, let's highlight it a little bit, that there is a slight change. Sometimes it's a big change, but this is not. It is simply a matter of flip-flopping the OH and the H, and that goes from making it glucose to galactose. So isomers are simply when you have all the same atoms, but they are not in all the same places. I hope that helps. If you have more questions, let me know, and we will go over it.